So here's what's happening with this problem. Problem 308, part 1. In the first part, well, so here is a bunch of data, and we've made a line of this to go through it. And in the first part, we will really just want to find the equation for this line. We can tell what are we comparing. We're comparing wrist circumference for our x value, and we're comparing height for our y value. All right. So when we do this, this has all been spit out for us by itself, I guess. Here is our r value. Here's r squared, right? These are the ones we care about. Okay. When we were making up our linear equation, we have to remember the equation for our line. So y is equal to mx plus b. M being the slope, x being our variable, so we won't change that, and b being the y-intercept, which is the place where our line hits the y-intercept. We actually can't see the y-intercept here because it's not included in the graph, but remember the y-intercept happens when x is 0, so if we had x values that's smaller and smaller and smaller, we would show our y-intercept. Anyway, the coefficients are listed here. Our intercept is this number. Go ahead and type that in, 38.2473. And so this is the coefficient, right? Coefficient of the x value. So remember, x was wrist circumference, and so the coefficient for the wrist, the x value would be 4.4305. And we can check out the preview here and see if it's okay. Syntax, okay. So now this is our equation, right? Y is equal to mx plus b. Alright, let's go down a little bit. The correlation coefficient. Our correlation coefficient is our r value, right? So it's this number. And the coefficient of determination is just r squared. And so let's talk about these two numbers briefly. Basically, see how these dots aren't really on the line. The closer the dots get to the line, the closer this r squared value will be to 1. That's actually also true for this. This will also be close to 1 too, if the dots get closer to the line. It could be close to -1, this value here, the r, if this value were negative, or if our line was going down like this, we had negative slope. So r squared, the coefficient of determination, if this is close to 1, these dots are closer to the line, which means our relationship between wrist circumference and height have a linear, or more linear. Here they're kind of spread out. So yep, you can put that in there. Let's look at this one. Use the equation of the line of best fit, that's this line of best fit, to predict the height of a person with wrist circumference of 6 inches. So wrist circumference, remember that's our x value. What you have to do is you have to take this 6 inches and you plug it in here for x, and then you compute what that is. 4.4 times 6 plus this thing. And then I think you do similar stuff for this. One point is this thing. The mean wrist circumference is 6.99, so you plug that into your equation. Yeah, so that's basically what's happening with this problem. If you want to talk about it more, post in this forum. Thanks.